Hi students, today we have discussed the important topics of wave optics. So in wave optics there are important phenomena. One is interference, second one diffraction, third one polarization. Before going to these phenomena, we can learn the basics of wave optics. Then, what is wave optics? See, in diagram, we have a transparent glass substance. Transparent glass substance. We can place the white light. We can place the white light on transparent glass crystal, then it will convert, then the white light will convert the different, that is Vibgyor colors, the set of Vibgyor colors will form by using this transparent glass crystal, right? So we can see in nature also the same phenomena will happen. The biggest source of light is sun. The biggest source of light is sun. So based on sunlight we will have a different kinds of length by different wavelengths and different colors. So we can learn the intensity and wavelengths of different kinds of colors in future classes. See, what is wave optics? The wave optics is study of light, how light behaves with, and it's when propagates there as a wave. The light, which is the propagation of wave, or how to behave with matters, how to behave with matters or molecules. So this is the wave optics. That is, the wave optics is a branch of physics that deals with the nature of light. What is that? The nature of light based on the wave theory. First, Dutch physicist Christian Huygens. So the famous scientist Huygens in 1678, he propounded and he found the wave theory of light. So wave optics is the use of study of propagation of light and understand how it is interact with matter. So the light, how it is interact with molecules, with matters, with water, in air, in glass substance, whatever objects are is there, how light will behave with that object. So this phenomena is known as wave optics. So what is light? What is light? The light, the generally the light nature is, it is electromagnetic wave. The light is electromagnetic wave with radiation. The radiation with refers to the visible region. Visible region means what? The human eye. The human eye can see or able to see the light. So what is the wave? The range of wavelength the human eye can see, that is 400 nanometers to 760 nanometers. So the range between 400 nanometers to 760 nanometers, which is visible to human eye, that is known as light. See, if you see the in diagram, the wave is transferred from one place to another place. Not a transfer, it travels from one place to another place. The wavelength, the wavelength, what is wavelength? The finite distance between two consecutive points. The finite distance between two consecutive points, that is known as wavelength. Okay, the peak, here it is the peak. What is peak? The highest intensity point, the highest wavelength point, that is known as peak. And what is amplitude? Here it is amplitude. The amplitude means the peak of the curve, how much it is increases as an intensity, that is it will be referred as amplitude. So this whole phenomena we call it as wave. Here the upper side curve, that upper side wave, that will be known as crust, and lower side peak will be known as trough. Generally it is upper side will be crust and lower side will be trough. Okay, so what is light? Light is an electromagnetic radiation which is visible to the human eye, the range between 400 nanometers to 760 nanometers, it is known as light. So what is the general definition of light? See, the wavelength of a sin wave nothing but a wavelength of wave, that is lambda, from, see, here it is from here to here, that will be the wavelength. The wavelength we can represent as a lambda. It can be measured between any 2 points with the same phase, such as between crust and trough, that is known as wavelength. So then what is frequency? Frequency is a wave of number which is passing a point in certain time. So the time of traveling of a wave with the time which is normally used the one of the in 1 second. The wave which travels in second of time, that will known as frequency. Okay, here it is, see, the in diagram we can observe here it will be the amplitude and here it will be the time. The wave which travels with low frequency, the waves which is traveling in medium frequency, the wave which is traveling with high frequency. So what is the difference? The time is difference. So based on the time, the frequency will vary. Okay, in frequency we can represent, that is hertz, the units, that is hertz. So the frequency is the units hertz, since 1 hertz is equal to 1 wave per second. Next, waves of different kinds. We have 2 types of waves, that is electromagnetic waves and mechanical waves. So we can see the difference between electromagnetic waves and mechanical waves. Generally, what is mechanical waves? These oscillation of matter may be characterized by waves. So all types of waves, but characterized by waves, the transport energy, these waves require a medium. That is like sound waves, water waves, rope waves, and so on. All are the examples of mechanical waves. So what is mechanical waves? Mechanical waves are characterized by wave, but the transport of energy from one place to another place, it needs medium. It needs one medium. The waves are like sound waves, water waves, rope waves, etc. and all. So what is medium here? So what is medium? The waves which travels the wavelength by using a medium, that is known as mechanical waves. What is electromagnetic waves? The waves are all generally a formation of waves, but in electromagnetic waves do not demand any medium. They don't need any medium at all to distribute their energy. They don't need any medium, but the energy will be distributed, like X-rays, gamma rays, UV rays. These are all comes under electromagnetic waves. So the electromagnetic waves, the speed will be 3.0 into 10 power minus 8 meters per second. Okay. In mechanical waves, sound waves faster in steel. In mechanical waves, generally we can observe in our daily day life, we can place one sound in steel. We can touch or give a pinch of touch of the steel. The mechanical waves, the sound waves will be produced, right? See, in the diagram, here it is the mechanical waves. Here it is mechanical waves. The waves which is travels through the axis. So here will be the wave. It needs one medium here. It needs one medium. In electromagnetic waves, they don't need any medium, but it can distribute the energy. It can distribute the energy. Generally we call it is, see, here the directions. What are the directions here? X, Y, Z directions are there. So here the blue one will be the one wave, and the energy which is distributed to another field, that is electric field. So this is the main difference between mechanical wave and electromagnetic wave. Next, what are the characteristics of wave? So coming to characteristics, as a wave, it has to satisfy the certain characteristics. That is, one is wavelength, displacement, amplitude, time period, and frequency. We don't discuss in deeply about the characteristics. So simply we can see in the diagram. We can see the diagram. The wave is traveling. The wave is traveling in wave motion. So what is wavelength? From finite distance of two consecutive points. Finite distance of two consecutive points, that is wavelength. Wavelength. Here, what is amplitude? Differentiate here. The amplitude, that is the axis which is traveling through the direction from the axis to peak, lower or upper, that is crust and trough. This area, that is called it as amplitude. Okay, that is called amplitude. So what is here? It is, see, this is the equilibrium stage. Equilibrium stage means what? There are equal for crust and trough. It is an equal in position, that is waves. So that transverse waves. What is the time period? Already we know the time period and frequency too. So this is the simple diagram and characteristics of the wave. Then coming to next one. So what is phase difference and path difference? So mostly it is very important to understand before going to interference. The path difference and phase difference we need to understand. So that is most important. So what is phase difference and what is path difference? See, I mentioned so many diagrams here, that is coming to see phase difference. What is phase difference? Here it is, two waves are moving along the axis, and here is the difference. What is the difference here? Two consecutive waves are traveling, and the equilibrium position. What is equilibrium position of two waves? These difference is known as phase difference. Okay. Then what is path difference? Here also same, it is two waves are traveling, and the waves, the must be wavelength should be from one wave to another waves. that will be path difference. So we can see here it is lambda by 2, sorry, pi by 2, then it is pi, 2 pi, then it will be 2 pi by 2, then 3 pi, 4 pi, so etc. along going to the up to n. So phase difference and path difference is the most important for the wave motions. Then what is phase difference? Phase difference is a difference in a phase angle between 2 points of a wave. 2 points of a wave, it is measured in radians. Okay. And what is path difference? Path difference is the distance between 2 points of wave. 2 points of wave. It is measured in terms of wavelength or meters. Okay. So this is the main difference between phase difference and path difference. Next, wave optics theories. So till now we discussed what about wave optics, then phase difference, path difference, different types of wave optics, etc. Now, theories of wave optics. So what are the theories we have? The theory of interferences, theory of diffraction, theory of polarization, Huygens principle, Fresnel equations, Maxwell electromagnetic theory, etc. There are different methods of wave optics theories. So we have just in our engineering physics, we have only 3 phenomena we are majorly focusing. That is interference, diffraction and polarization. Before going to interference, we need to learn and know about what is coherence, what is coherent source. So what is the source we have? Biggest source, that is we already discussed about sunlight. Sunlight is the biggest source of the light. So the light, if you can see the diagram here, sun is the source and the light which is travels through the slit, that is source 1, and it will diffracted or as a barrier. It is a single slit. Here it will be the double slit. So we don't much bother about what is single slit, double slit. Now we have to just know about what is coherence. What is coherence? The source, the two sources, like it would be emit light waves the same frequency and nearly same amplitude. So the two sources which is coherent, with two coherent sources, that is same which is travels same frequency, nearly same amplitude, are always in phase with each other. These known as coherent source, that is two light waves which is emits and travel with the same frequency, nearly same amplitude and are always face each other, is known as coherent source. Okay, it is enough for our study. It is enough for our coherent source. See, in actual practice, it is not possible to wave two independent sources which are coherent. But for experimental purpose, two virtual resources formed from a single source can act as a coherent source. So what is coherence? Two sources said to be coherent. It is emit and travels with same frequency and almost same amplitude and always with the same phase each other. This is known as coherent source. Clear? So this is the coherent source. Next, what is superposition? The principle of superposition. What is superposition? The two or more waves. What waves? Coherent waves. The two or more coherent waves Superimpose in a medium, superimpose in a medium, the total displacement at any point is equal to vector sum of individual displacement of waves at the point. Okay, so what is the principle of superposition? Two coherent waves superimpose in a medium and which is travels with same frequency, same amplitude and nearby same wavelength, that is known as the superposition of light. Superposition of light, that is known as interference, that is different concept. But what is the principle of superimposition? The two or more waves superimpose in a medium, the total displacement at any point is equal to vector sum of individual displacement. See, for example, here we have three waves. If you observe, here it will be the green and here it will be the light blue. These two waves are traveling. Okay, then here it is the yellow wave. The yellow wave is the superimposition principle. The superimposition principle, if that is y1, y2, y3 are two different displacement vector due to the waves, that is 1, 2, 3, it is acting separately, then according to the principle of superposition, it is a resultant displacement. What is that? Here it is the yellow light is the resultant displacement. So that displacement is known as y equal to y1 plus y2 plus y3. That is how many waves we have, number of waves if it is have. So the resultant displacement will be total number of displacements. So this concept is known as principle of superposition.